Yay!
Yay! Hey everyone, here's a quick problem to watch out for, and this is a problem involving friction. And this looks really simple, right? It's just a mass. Now it looks simple since we've done other stuff. It's just a mass sliding on a horizontal surface. I got F. But I'm pulling this thing with maybe a string, and the string is inclined at an angle, right? So there's friction. And I want to find out what the acceleration is. I know, let's pick F is 300 newtons. The mass is like 40 kilograms. It's a heavy box, 30-degree angle. Okay, so what's the acceleration of that box? The reason I picked this example is because I'm going to point out something where you got to be a little bit careful. All right, so here's the normal force is going up. Whoop, I've sort of covered it up, haven't I? I didn't draw that very well. What if I do this? Can I do this? Will this software let me do this? Can I just move the, oh, look at that. Just move the whole thing. Look at how fabulous that is. Okay, great. Look at that. All right, so here we go. Here's our normal going up. We see that? Yes, we can. And then I got mg going down, no problem. I'm pulling to the right, so I know that my friction is going to be to the left. And I think I've established that friction is red because it hurts when you slide on something. So there we go. So there's our friction acting back to the left. Okay, let's go ahead and just do the regular thing. So summing the forces in the x direction on this thing. What have I got? Well, I don't have all of F. I've just got a component of F in the x direction, and you already know that's F cosine theta. Neat. And then I got my frictional force headed back the other way, and this equals ma, right? Sum the forces, it equals mass times how it accelerates. What about the y direction, the fy? What do I have? I got n going up, I got minus mg going down, and then, ooh, here's where you got to be careful. Look, there's a component of F that's in the y direction. All right, we can't forget that. Here's the whole reason why I'm doing this problem, is because after doing a whole bunch of these, which you should do, right? Lots of homework. You might get used to the idea that if it's horizontal, you might just instinctively write down N equals mg, because you do it over and over again. Normal force is equal to the thing's weight if it's horizontal. I'm just saying sometimes you got to be a little bit careful. So there's a little bit of F going in the y direction, positive y direction, so I have to add in F sine theta. Sure enough, it equals 0. We don't want it to come off the ground. But there's a little bit of force in the y direction there. What's the action of that? This totally makes sense. Look, because now N is mg minus F sine theta. Look how much sense that makes. Normally, N would just be mg, right? That would be its normal ordinary weight. But I'm subtracting off a little bit of the force. I'm making it lighter, right? Because if this thing were on a scale, the normal force is sort of like the weight you would see on a scale if this thing were sitting on a scale. And if I'm pulling up on it a little bit, the normal force is going to go down. The scale is going to read a little bit lighter, right, as I'm pulling up. So this makes total sense. I'm subtracting a little bit off of the weight. Okay, so we just have to be a little careful. But now we're kind of ready to go. So now that I want to solve for A, F cosine theta minus F is mu times N, mu times the normal force. So this is mu times mg minus F sine theta equals ma. So we should be all set. So this is going to be A is F cosine theta minus mu mg plus, gotta do the minus signs right, mu F sine theta, and then I'm going to have, I'm going to divide out m. All right, and then if you plug all of your numbers in, what you're going to get is, what did I get? 4. Okay, whatever. It's not, the final answer is not so terribly important. It just depends on what numbers I chose to begin with. But the process is what was important. That's the thing I wanted to kind of point out that you have to watch out in the y direction for any other forces. Don't always get so used to the idea of N equals mg if it's horizontal that you just stop thinking. Cool. So that's how to treat this one. So on we go.